So today, to continue with the idea from last week, I'm gonna be drinking this oolong tea. It's a high mountain tea from Taiwan. And if you want to introduce someone to teas, and he's not a big fan of black teas or like he thinks all teas taste the same, this is probably the best tea to introduce someone to tea. So full of flavor. Hey guys, Ombarus here. So today I got a suggestion on one of my previous video from Zoltan Nemeth that said that I should do a beginner's mistake as programmer video. And I thought it was a really good idea. And I started really thinking about what kind of mistake I made as a programmer. Have you guys done any of these kind of mistakes? Do you have something you can talk about in the comments? For me personally, I think a developer develops more like trauma as they grow older. I have some personal issues with certain things that come from experience, and I'm gonna talk to you a little bit about these. The first thing is statics. I hate static. And I'm not talking about global variables. Everyone knows global variables are evils. I'm talking about the static keyword you find in many programming language. One of the reasons I hate that is that once I was working on a game engine that had a lot of static components. So the player was a static, the menus were all static, the HUD, the heads-up display for the player was all static variables. And then you'd think, well, who cares? Why on earth would you need more than one heads-up display on a single game? And then my manager came and he asked me, can you do split-screen multiplayer for up to 4 players? And I was like, well, shit, I need 4 heads-up display now. And it was such a huge mess because everything was static, everything was like keeping pointers inside data structures, and it's, please don't. Just save yourself some trouble. And another reason why you don't want to have static is that if you're using a language like C or C++, you will eventually run into memory leaks. And how do you usually debug memory leak? When the easiest way is usually just to keep track of your allocation, and when you quit the game, you check for whatever is left. But if you have static, what do you think happened? The statics don't get unloaded, so you get stuck with a bunch of false positive. And if you ever think of loading all your JSON data into one static variable, then don't. Because you're going to end up with so many objects that don't unload at the end of the program that you'll never be able to find memory leaks. Now, I'm not saying that statics are not useful and that you shouldn't have any managers of any sort. Hell, the system I'm developing right now with an ECS and Godot is basically all a bunch of managers, but they have a scope. They're nodes and they get loaded and unloaded. Next, we have debugging skills. Now, I hate looking at other people's code just as much as the next guy, and that includes my own code if I haven't seen it for 6 months. But the fact is, 90% of your job as a programmer is going to be debugging. I remember when I got my first internship thinking, why did I spend so much time learning how to code? All I'm doing is debugging. And it's true. And no one cares about it. No one teaches you how to debug. But it's a skill, and you have to develop it, and you have to work on it. Because you don't have to love debugging, but if you accept that you need to develop it, then you're going to be that much more of an awesome programmer in the future. Which brings me to the next point, problem solving and how to break down a big problem into manageable parts. I remember when I was a kid, often I'd say to my mom, Mom, where are my shoes? I can't find my shoes. And my mom would always reply with, well, they're certainly not on the ceiling. Why don't you try looking on the floor? The truth is, when we don't know what to do, we kind of fall into despair and our thought process freeze and we just don't know what to do. So it's important as a programmer not to get bogged down into a problem and just freeze up. You have to think ways to solve all the issues you find. Even if the problem seems huge or impossible, you have to kind of try to analyze it. Of course, the first thing to do is just to Google it or look on Stack Overflow, try to find keywords, search for whatever information you can get, follow the links through and look at other stuff that's connected to what you're looking to solve, and then start thinking about the problem in your head and try to make notes, write stuff on paper, try to have a brainstorm between you and a piece of paper, and then try to start figuring out what's the most tiny bits of thing you can start working on to get it done. Even if it's only remotely connected to what you're trying to solve, just try to start working on something. It doesn't matter what, just a tiny bit of something. Just take a bite out of it. And if you're really desperate, then just look for help. Try to ask some other programmer, try to ask someone sometimes even if they're not programmer, they might have suggestion about your current situation. I remember a few years ago, my team lead came to see me and he said, "You're going to make a projection shader that's going to project decals onto a car texture and bake it in the texture." And when he said that, at that time I remember thinking, shaders, well, that's something to do with graphic cards, right? But you know what I did? I wrote down exactly what he said to me, and then I turned to him and I said, "Okay." And I get to work. And the first thing I did is look up what the fuck is a shader, and then how do you make a projection shader? And then I started looking at, texture generation, because if I'm gonna bake texture, it probably means I have to write some texture. And then I went into the project and I look at how the texture was implemented for the cars, how it was binded, how it was working. I even look at the engine source to try to figure out, how I'm gonna do this. And eventually I managed to do it. It took a couple of weeks, but it was one of the proudest moments of my life where I managed to finally make it work. One thing that's helped me solve a lot of problems was going for a walk. And I'm talking about a physical walk. Sometimes it just helps to clear your mind. You stand up, you go walk a little bit. When I was working in an office, I'd go to the stairs and I'd go up and down the stairs. It's a good physical exercise at the same time. And you really just need somewhere a little bit quiet and without any distraction to help you think. I even heard someone, I don't really remember who, but someone once said that he measures problem in distance. So if it's a simple problem, he'll be like, "Oh, I just need to take a walk around my desk and I'll figure it out." And then if it was something a little bit more complicated, he'd be like, "Oh, maybe I'll go out and have lunch today." And then if it was a really big problem, he'd be like, "Oh shit, well, I guess I'm walking home today." And it really is like that. Sometimes you just need to walk it off. Programming is really about what the customer wants. It's about communication, understanding, and yes, maybe sometimes giving up on your perfect architecture. Now, I think there's kind of two schools of thoughts there. One of them is the kind of Linux guy, and one of them is the Apple guy. So the Linux guys are like all about the beauty of the code and the architecture and Linux is beautiful, it's well built, it's modular, it's infinitely customizable, it's awesome. But then there's Apple. Apple, my grandma can use Apple. The thing is you have to strike a balance between these two extremes, if you will. You need to be able to reach all your customers, but at the same time you want something that will be easy to maintain and everything. And it really depends on what you're making. If you're making some kind of website or portal that will be online and be there for years to come, then you need something very, very well built. And you shouldn't make too many sacrifices for your architecture. But if you need something like a game that will be released, maybe people will play it for a couple of years and then it'll fall into good old games, then you can make some sacrifice for the sake of usability and reaching more people. One of the things I found fascinating about software engineering is that you're not making just software, you're making software for something. You see, an accountant is playing with numbers, a doctor is trying to heal some patients, and like a race car driver is just trying to drive fast. But you don't make just software. A software engineer, he makes software for someone. He makes software for an accountant, or for a doctor, or for a race car driver. And that means you really have to understand the field you're working on. For example, a long time ago, I was hired by a small business to make a software for an accountant. It was supposed to be something very simple, just take orders and cancellation. And my first implementation was just, well, when an order come in, you add a line to the database, and when the customer canceled, then you just delete the line. But the accountant went crazy when she saw that, because you never ever remove something in accounting. You always have to keep traces of what you've been doing, and you always have to balance. A cancellation is not just removing an order. A cancellation is a negative order, and you have to show it like that in the database. And when I understood that, then I could make a much better software for this person. So what I'm really trying to say is that understanding the field you're working with when you're doing software engineering is of paramount importance to having a good software. Now, a word of advice. If you're a beginning professional programmer, I have one thing to say. Shut up and figure it out by yourself. You see, older programmers are usually really happy to help you with any problems you might have. But if you're coming to them every 10 minutes and asking silly questions, then they might start getting annoyed. And by silly questions, I mean, your question should never be your task. So if you're coming to a programmer and you're asking him, hey, do you know how to do decal shaders on a car? Then you're basically asking him to do your job, and he's gonna get annoyed. If you have a specific question for this problem, then by all means come and see him. He's gonna be happy to help. For example, go and see the guru if you have to ask something like, hey, I have made my custom car shaders and I have this custom matrix, but I'm not sure how to bind the matrix to the shader. Then that's a specific question and he's gonna be happy to help you. As for actual mistake I made in my career, well, here's a couple. A couple of years ago when I was doing an internship, I messed up whole kilometer of assembly line because I was testing my software on a microcontroller that I thought I'd put in simulation mode, but I had actually forgot to put it in simulation mode, so all my inputs were actually modifying the settings on the line, and it screwed up everything. And then once it happened that I was working for a company making electric motors, and I was testing this electric motor by trying to send 100 amps in it. And well, that's a little bit much. And the only reason the motor didn't bloom like a flower in the terms of my manager is because that the generator we were using had some failsafe in it that I wasn't even aware of. And all of this comes to the same thing. Check your shit before you do anything. It's not enough that your code compile. You should always double check that all the inputs you're expecting and even the ones you're not expecting work well. So that's about what I wanted to mention for this episode. What do you think, guys? Did I miss anything? Leave a comment and tell me about your personal experience, your traumas, and your issues you have as programmers. Bye, guys. See you guys in my next episode.